Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the C++ series. In this lesson, we're going to continue talking about classes and specifically how objects are copied. So if you haven't seen the previous lessons in this series, make sure that you go back and watch those. I'm going to be doing a full set of tutorials and lessons talking about classes, and it probably makes sense for most folks to start from the beginning. With that said, though, let's go ahead and do a little bit of learning about what it means to copy something in C++. So, the best way to start this lesson, in my mind, is to just go ahead and write a little bit of code and see what we're going to be talking about here. So I'm going to go ahead and just include the string library here. And let's just go ahead and create a string in C++. And we'll create something like Mike here and just assign it Mike here. And I'm going to go ahead and compile this code here. I'm going to use the C++ 17. This will work fine on any version of C++, but again, I like using modern stuff. Here's the main file, and we'll output the program here. All right, so let's go ahead and run this, and well, nothing too crazy so far. But let's go ahead and make it a little bit more interesting and print out what the string is here. So I'll print out Mike here, and we can go ahead and see what the result is. Let's go ahead and save that, rerun, and well, there we are. Now, again, nothing groundbreaking at this point here, but let's go ahead and create another object. So I'm going to go ahead and use the string type here, and I'm just going to go ahead and create a second variable here, Mike2 in this instance. But instead of assigning it some value or initializing this object, I'm just going to assign it to Mike here. And then we'll go ahead and print it out. And let's go ahead and see the result here. So Mike2, recompile, rerun, and well, it's almost like magic that Mike2 here also gets assigned the same thing that's stored here, which is the string or the 4 characters Mike and the null terminating character. So 5 here in total. So that's what's happening here is a actual copy. So we're copying this object. Now, how does that exactly work here? Well, let's go ahead and put to use some of the things that we have been learning here. So that's going to be the theme for today, learning about copies. So what I'm going to do is go ahead and just create a simple object here. And oftentimes this means something like a math data type here, like a vector3, which just consists of 3 numbers here. Okay, so I'm going to go ahead and just create this type here. Now, for folks who have been watching the previous lessons, you're going to notice I'm taking a shortcut here and just creating the class here as it is. Now, what I want to go ahead and show you is, well, how do I create an instance of this object? So my vector like this, and then I can just access each of the member variables or the fields of this class as shown here. So let's just go ahead and assign them some values. X, let's go ahead and do Y and Z here. And I'll just do this as follows. 1, 2, 3. And I like to give them different values here. Okay, so let's go ahead and just make this a little bit bigger here. Okay, do a quick compile here. Looks like I'm missing a semicolon at the end of my class, but this works here. And as you may recall from the previous lesson, well, C++ gives us by default a constructor. And for a trivial type like this, where I just have some primitive variables here, I get a constructor for free that can set up these variables, meaning that I can just create this object. Okay, and that's called the default or the compiler generated constructor. And the same thing for the destructor. So I don't really need to define these. Okay, now let's go ahead and see if I repeat that same experiment that I did with strings here and make a copy of my vector here. So I'm just going to create my vector2, and I'm going to assign it to my vector. Okay, and in order to see if this copy actually happened, well, we're going to have to print off everything from my vector2, the x value, maybe a comma here. Then we need to print out the y value. So my vector2 dot y, and a comma just to make things nicely formatted. And I'll actually put a space here. My vector2 dot z, and an end line to flush out the output here. Okay, so here's our program. And what I want to see is, did this in fact give me a copy here? So I'll recompile, rerun, and well, voila, 1, 2, and 3, which is printed out from my vector here. So clearly we can see the same thing that was done in a type that we created, which was the same as a string type. Okay, so this idea of making a copy when we initialize the object. And you can sort of imagine how this is going to work here. So if I go ahead and just draw my vector here that we created, as soon as we get into line 15 here and are creating an instance of our object with the type vector3 here, C++ is essentially allocating enough memory for us. So let me go ahead and just draw this to store an X, a Y, and a Z here. Okay, and we don't know what the values are until we actually assign those values, but I'll just put those in parentheses because we did 1, 2, and 3. Okay, and then I go ahead down to line 15 here, and I tell C++, hey, I want another vector here. So this is my vector 2. And it has 3 fields associated with it, and however much memory it takes to store a float. Typically 4 bytes on most systems these days, so X, Y, and Z. Okay, so we have enough storage for that. Now, when I have these very simple types here, a float, for instance, C++ has already allocated enough data for this, 4 bytes at a time here for each of these floats here. So when I do this assignment here, I am actually doing a copy, and I'm copying all the contents from my vector, so that's these guys over here, into my vector 2. Okay, so just doing a copy and just doing a copy here. Okay, so I'll go ahead and get rid of those and just show that we have our unique 1.0, 2.0, and 3.0 in each of these 2 objects. Here's our first instance of an object of type vector3. Here is our second instance of an object of type vector3. Okay, so I think we got the vocabulary down here, and this makes sense. So just to summarize, C++, when we create a class, gives us a default compiler generated constructor, destructor, and copy constructor. Okay, so those are 3 things given to us. So 1, 2, and 3 here with the copy constructor. Now I want to try something else here. First, I just want to show you that, well, if I didn't assign vector2 to anything, what does our default compiler generated constructor do? Again, there's no constructor in this function. So if I rerun this, well, I just get essentially garbage here because the C++ compiler doesn't know how to build a constructor that might initialize things to 0. So again, the appropriate thing to do might be to create a vector here and just assign x equal to 0, and then repeat that for y and z, or z here, and just get zeros all around. So it's usually a good idea to provide a default constructor so that we have control. Okay, but that's not what I'm concerned about, or rather the next thing that I want to actually work on here is to see what happens if I do my vector equals my vector here. So my vector 2, and I just do an assignment here. Now, normally when we've done this with variables, for instance, if I were to just say int x and y and just say x equals y, we understand what's going on there. So how does that work with the behavior of actual objects here? Well, let's go ahead and take a look. So I'm going to compile this, I'm going to run it, and well, this again is trivial. But this is actually something slightly different here. This is an operation or an operator. So let me go ahead and just label this the copy assignment operator. So we also get this for free, this functionality that C++ can create a copy assignment operator. And again, this type is very trivial, meaning that vector3 just consists of primitive data. So this is okay. So if we have a very simple data type like this that just consists of things like floats, integers, bool, all the built-in types in C++, so nothing that's a class, this can just work fine. So that's the first part of this lesson that I want to make you aware of, that we get these copy constructors. But now it's time to complicate things just a little bit, or rather not complicate things, but just make you aware of what if you want to create your own copy constructor and copy assignment operator, and why might you want to actually do that? Because recall in previous lessons, we created our own constructor, for instance, in our own destructor. So let's go ahead and get rid of this code here and create another example. And for this, I'm going to create another type here, and I'm just going to call it array. And I'm going to do something a little bit more interesting with this type here. And I'll try to more appropriately have some private members that shouldn't be accessed here, just so we can see an example of that. So let's actually get rid of string here. And what array is going to do is have a pointer in it and store some data. Okay, in our actual array constructor, perhaps we'll construct this data here. So let's go ahead and just allocate, say, 10 integers here. And let's go ahead and assign them. Okay, now I'm just going to do this using a simple loop. If you followed some of the other videos, you've seen more clever ways to do this. But let's just go ahead and assign each of their data a value I times I, just to make it less trivial here. Okay, and maybe we might want a function here for printing the data here. Okay, and again, that will just use a loop and print out all of our data. Okay, so let's go ahead and make this a little bit bigger so that we can see everything on the screen here. And we'll want to use standard out to do this. Standard out, our data, and one item per line here. Okay, so let's go ahead and test out our class to see if it works here. So I'll create an array object, my array. And just a stylistic thing, I do like to make these capitalized and follow a good case here. And our constructor should match the name of the type here. So there we go. So this is now constructing one object. And let's just go ahead and print out my array and do printing data here. Okay, just to see that it is actually constructed. Okay, so I run it and we are getting different values. Now, since I've allocated memory here, I should also write a destructor. So let's go ahead and add to this class a little bit for our destructor. And we need to delete, and because we have an array of data, the brackets and our actual data here in the array. Okay, so now we've cleaned up after ourselves and things are working well enough. All right, so this seems pretty fine, and this is an array where we are allocating some memory here. All right, so nothing too wild here. We've created a little wrapper around a allocated array, and again, maybe we want to do some more interesting things here, such as setting the data in our array. So set data, perhaps at some index, some value. Okay, so we'll access our data at some index and assign it a value. Okay, so let's go ahead and do that here. My array dot set data. Let's do index 0 and set the value to something pretty distinguishable, 100,000 here. I'll recompile and rerun. And we can clearly see that the first index has been set to 100,000 here. Okay, now let's get to the point of this and what we're talking about with our copy constructors and what I want to show you here. So here's all the code on the left side of the screen that you can see. Go ahead and review it, and we're going to move on here. All right, now what if we go ahead and do basically the same thing that we did previously, where we tried to create a copy or do the copy assignment. So I'm going to do my array 2 equals my array. And then I'll do my array 2 dot printing data. Okay, so let's go ahead and just print out all the data here. So again, we're just doing this copy assignment. Now, when I compile this, this is going to work because, well, even though I haven't shown you yet how to create a copy constructor within this class here, well, C++ always gives us that copy constructor, copy assignment, and a default constructor or destructor if we don't define it. So we should be okay with that idea. But let's go ahead and see what happens when I run this. And well, this is kind of interesting here to see what happens. Well, it appears that we got this copy constructor and it worked for free again, okay? But this can be a little bit deceiving. So let's go ahead and try to set some data here at different indexes here. So I'm going to go ahead and change some of these. So 0, 1, 2, and just give these some random numbers here. 77, 999, and so on and so on. And I'll go ahead and compile this program, and I'll go ahead and run it with /prog. And well, let's see what happened here. Well, again, it looks like the copy worked here. Okay, but maybe I ran through that a little bit too fast, and we're seeing something interesting here at the bottom here. It looked like our values are getting copied here, or something interesting is happening. But well, what's actually happening here is interesting. I'm getting this error free, double free detected in tcache 2, whatever that means here. Okay, so let's try to investigate this a little bit more to try to figure out what's happening. Okay, and the way that I'm going to actually approach this is by rearranging a few things here. So let's say that, again, we're structuring our program, we're trying to be good programmers, and we initialize all of our data up front. Okay, so let's go ahead and create our arrays here. And maybe we might do something like this. So we have 2 arrays and we say, yeah, they're just going to be copies of each other here, and that's fine. And then we go ahead and set some of the data here. Okay. And then we print out the data. Now, what to observe here that might be interesting is to observe that we're only setting the data for my array. And then we'll print out my array. So again, if you haven't seen C++, you might expect that my array is the only data that changes. Okay, that makes sense. I'm doing my array.setData here, and at the index 0, 1, 2, and so on. And then I print out the data for each of these. So let's go ahead and try this to recompile, rerun, and again, we see something suspect here. So something is going on here. Well, I get 177, 99 for my array 2 when I am printing out the data. So what do you think is going on here when we look at this? Well, again, remember the compiler gives us a copy constructor for free, which I haven't shown you yet, but it is something that allows us to just make a copy of these objects. So let's go ahead to the whiteboard here and try to understand what's going on here. So I'm going to go ahead and get rid of my notes here. And let's look at this the same way that we looked at my vector. So let's go ahead and just call this array. And well, we have my array. And what fields does it have? Well, it has int star data here. Okay. And then we create my array 2. And well, what does it have? Int star data as well. So when I make a copy, what's the most trivial thing that a C++ compiler can do? Because remember, this is a trivial copy that it's going to do. Well, C++ is just going to say, hey, whatever this data is now equal to this data here. So essentially, it's just saying my array dot data, or rather, since we're making the copy of my array 2, so let me go ahead and do this down here. My array 2 dot data equals my array dot data. So take a moment to think about that. This array is just being set equal to this array. So they're pointers. This memory is just pointing to whatever is stored here. And that's something that is just trivially done by the compiler, because it doesn't want to assume, but maybe what we were really thinking, or what we really want to do, is to create our own memory for this data. And that's not happening here. So C++ gives us a free, and I'll say free as in it just writes the code for us, copy constructor and copy assignment operator, which I'll again remind you the difference. But it does what we call a shallow copy, which is basically what we see in this box here, which is the most trivial thing that it can do, just a simple assignment. And if we've got things like pointers, for instance, that means we're pointing to the same memory, and that's why we get this double free detected. Okay, because once we've freed the memory in this first array, once it goes out of scope, we attempt to free the memory in my array 2, and that's just pointing to my arrays 1 memory, which has already been free. So this is quite dangerous. What we really want, and what I'm going to show you here, is a deep copy for memory, for dynamically allocated memory. Okay, so anytime that you're using new, malloc, any memory allocation function where you have a pointer, typically you want to write your own copy constructor and do the memory allocation yourself. So let me go ahead and show you how to do that. All right, so how do we first write the copy constructor? And you might want a little review, or to actually see this, you can search on CPP reference the copy constructor page and see copy constructor syntax here. So I'll go ahead and scroll down and show you how to do this, but here is the documentation if you want to see the copy constructor syntax. I think it'll be easier if I just go ahead and show you. So let me go ahead and label this copy constructor. And basically what we have for our copy constructor is it'll be named the same thing, but we're taking one parameter, and this is the thing that we're making a copy of when we're initializing our object. So that'll be the actual type here. And typically the thing that we're making a copy of, we don't want to change. So we make it const here. And we're passing in an actual object. So we're passing in the value or the reference type of this array here. And sometimes I just call it the copied object, or sometimes we just think of this as the right hand side, which I'll just abbreviate RHS here. Okay. All right. So what does it mean to make a copy of this array here? Well, it means that for us, we have this data. It's already been allocated, for instance. So we've got to figure out what to do here. So typically this means just delete all of our data that we have, and that clears out our memory. In this instance, we would probably want to reallocate that memory here. And for this example, I'm just saying it's 10 integers every time. You might have a size variable or something to help you figure that out, but we reallocate the memory. And then what we do is we say for I less than 10, I++, again, because we have 10 things allocated, we would copy the data here for our current object that we are copying into the right-hand side data. Okay. And by doing this, again, we are allocating new memory. We can see that there's an actual new reallocation of our memory here. Okay, so let me go ahead and recompile this so you can see it working here. And oops, looks like I got a little error here. So let me go ahead and fix this here. And the reason I got this error, let me go ahead and just scroll down here, is, well, have we actually called our constructor and allocated anything? Let's go ahead and just print out here. Constructor, and I'll go ahead and put an end line here. And let's just go ahead and paste in copy constructor. And when learning these things, I like to give myself this little cheat where I can actually just print out which of these functions is called. And it'll be a little bit helpful here. So let me rerun it and let's try to figure out where this error came from. So I see one constructor being called and one copy constructor. Okay, so if I go ahead and scroll down here, I'm creating two objects. This one's the constructor and this one's the copy constructor. So there's actually nothing to delete here, because we're creating our memory for the first time. Okay, so let's go ahead and rerun this. And now we'll see that the constructor is called for our first myArray. That's this one here. And then myArray2 is created, again, constructed, that's part of the name, copy constructor, separately. Okay, and we can now see that, well, we're creating this object here, copy constructing it, and then assigning the data only to myArray. And then when we initialize our second myArray, it's been the original contents of myArray here. Okay, now we'll go ahead and just rearrange things a little bit here so we can see the actual copy being made. So this time I have myArray. I'm going to set the data here. That's of these first 3 elements. So we should see those 3 elements copied in here, but we shouldn't see any errors at the end reporting double free or anything like that. So let's go ahead and recompile and rerun, and voila, you have a valid constructed object here with its own memory. Because again, the copy constructor is allocating dynamically its own memory here. I'm doing new int here for my copy. It just happens to be that I'm initializing it, or during the construction phase of the object, I'm getting it from the right-hand side of the equation here. What's the right-hand side? That is my array here. Okay, so that's the copy constructor, and I think we have a good idea of what's going on here. And now I want to show you one more thing, which is the copy assignment constructor. So copy assignment constructor. Or excuse me, I should say copy assignment operator. Let me be specific. So this is called for when after an object has been constructed. So object is already constructed. We are just making a copy later. So for instance, this would be if we just said myArray2 equals myArray. So it's already been constructed. Okay, so let's go ahead and see how do we make this. And this is going to be our first notion of this operator, but this happens when we use the equals operator or the assignment operator. And likewise, we are making a copy, so the parameters are going to be the same, of something that's on the right-hand side, or sometimes folks call this copy or right-hand side copy, however you prefer to do this. I'm just going to do right-hand side. And this time we are actually returning to our object here. So I'm going to return a reference type here to our object. Okay, so let's go ahead and see how this works here. And I'm going to go ahead and create our little printout here. And let me go ahead and call this copy assignment operator, just so we can see when this is actually called. So let's go ahead and refactor our program a little bit. So I have my array, so there should be 2 constructors here. And then if I call my array2 equals my array, this is where the copy assignment operator should be called here. Okay, so let's go ahead and recompile it. And we are getting a warning because we haven't finished that object, and we might get a crash here. That's okay. But I do see 2 constructors called, just like normal here, 2 constructors, and then this new copy assignment operator called. Now I haven't done anything interesting here yet, so let's go ahead and figure out how to do a copy so that when I reassign my data later, I should have these values 100,000, 777, 999 as the first 3 values here. Okay, so our copy assignment operator, the first thing that we want to do is check if the right-hand side, that is this object, is equal to this. And what is the this pointer? Well, this refers internally to the actual object. So I don't want to make a copy of the object itself. That is, if I were to, for instance, just say my array2 equals my array2, that doesn't really make sense. There's just no work to do. Okay, so we handle this sort of condition here where we say, hey, if the address of the thing that I'm bringing in, this object, is the pointer itself, then don't do anything. Okay, so we check for that equivalence here. Okay, and then what do we return? Well, we would just return, we could either just return as normal or just return the object back itself. So this, which is a new idea, maybe if you're a Java programmer, you've seen this before, but it's just a pointer to the current instance of the object. And if I dereference that, I'm just getting the array object back itself. Okay, so that's the idea. So let me go ahead and compile this. And it works, but we have to figure out how to actually do the copy. So now this time, what I'm going to do is delete all of our old data, because we want to be copying into the left-hand side what's in the right-hand side now. Okay, so let's go ahead and delete the data. And we might want to do some things like say, if data is not equal to null pointer, then delete the data, and so on. But I'm just going to make this as simple as possible for now. Okay, so once we've deleted our data, we would want to reallocate for whatever the size of the data is in the other object here. In this case, it's always 10 integers, and then perform the copy. And then we return the object back here. Okay, so let's go ahead and run this and compile. And now we have our copy assignment operator implemented just like that. So the signature looks pretty similar to the copy constructor, except we're now using this operator symbol for equals. And equals really you can think of as a function. We think about it as a symbol here, but it's really just a function here. And this is where it's being called. Okay, so that is the copy assignment operator, and it's properly deallocating all the memory that exists here on our left-hand side, reallocating memory for however much data is in the right-hand side, and one element at a time. If I scroll up here, copying in each of the data here, and then we just return the actual object. Okay, so it's quite a few things to get used to, but some tips as we wrap up here. The first tip is that one, print out the copy assignment operator or copy constructor just so you can see which one is being called. In fact, print out the constructor too, just so you can delineate the difference. I see folks often get confused with these copy constructor and copy assignment operator. Just remember that this one has the word constructor in it, so that implies when you're building an object for the first time. And that's when this one's called. And we're going to look in another video, this one's already getting long enough, where exactly the copy constructor is actually called, and you'll be surprised how many copies are actually being made sometimes. And this is where things like move semantics and so on can be useful, which we've talked about in a previous lesson. So folks, with that said, thanks for joining me on this lesson. I know it got a little bit long, but hopefully this topic got the treatment that it deserved, and you learned about copy constructors and the copy assignment operator. I think these are really valuable topics and that you'll need to understand to be a C++ programmer. And in order to continue learning some C++, again, I hope you'll subscribe so you can see the next part as we continue talking about classes. Thanks for your time, folks.